In this module, we'll look at the Centralized Crew Alerting System, or Ccas. First, we'll examine the general architecture and logic of the system, and then the different levels of alerting. Finally, we'll cover operational specifics and associated alarms. The Ccas system is designed to monitor all the ATR systems and provide warnings for malfunctions, abnormal situations, and flight envelope deviations. The system uses both visual and oral annunciations to warn the crew of problems. Annunciator lights on the ATR follow a lights-out design principle. This means that all control panels will be dark if the systems are functioning normally. A fault or failure will then be evident by the associated amber light. The Ccas components include a computer processor, the Centralized Crew Alerting Panel, or CAP, flashing lights for master warning and master caution conditions, and aural tones. The CAP is a panel of annunciator lights used to provide initial identification of which system is experiencing a problem. When a system problem occurs, notification takes place by way of a local alert for that system. This will be an illuminated light on the associated push button for the system. This alert gives the crew a specific idea about what is wrong. The system failure will then signal the central alerting system, and an annunciator will light up on the CAP. The system architecture allows for local alerting in the event the MFC fails. This is indicated by an MFC light illuminated on the crew alerting panel. In the event of an MFC failure, there would be no central alerting, and the crew will have to monitor local panels for any faults. A few systems are only associated with a central alert on the crew alerting panel. The annunciators for these are parking brake, GPWS fault, and maintenance panel. These alerts will only appear on the crew alerting panel and can only be extinguished by corrective action. Basically, system alerting occurs in a three-step process. First, the fault or failure is detected and processed by the MFC. The crew is then notified by aural and/or visual alerts. Second, the crew checks the crew alerting panel to see what system has been affected. The light on the CAP will then indicate what specific system is having a problem. Finally, the crew finds the illuminated push button for the system that has faulted and takes the appropriate action. Some alerts are not processed by the MFC, so the only notification that takes place is via local alerts. This applies to the following conditions: engine fire, excess cabin differential pressure, excess cabin altitude, nacelle overheat, and smoke. The warning system signals problems differently depending on their severity. Situations that require immediate attention by the crew will trigger the master warning lights and a continuous repetitive chime. Situations that do not require immediate crew action are indicated by flashing master caution lights and a single chime. The master warning and master caution lights are two flashing push buttons directly in front of both crew members. They are designed as attention grabbers. When a button is pressed by either pilot, both the flashing and aural alerting will stop. Click on the master caution light to extinguish it. The master warning lights are red and indicate an emergency situation. The master cautions are yellow and indicate an urgent situation. Ccas alerting has been prioritized into 4 levels. Level 0 alerts notify the crew of conditions that are not abnormal, but are of a temporary nature. Lights for these conditions are blue. green, or white. No special action is required and the Ccas system is not triggered. Generally, they are just notification of a system's condition, such as the propeller brake on, or external power is available. Level 1 alerts also take place without Ccas activation. They generally signal the degradation of a system or loss of redundancy, and only show up as a local alert. This is usually indicated by an illuminated push button. Level 2 alerts are designated as cautions. These will be accompanied by both yellow master caution lights flashing, as well as a single chime aural alert, and an amber light on the cap. A Level 2 condition does not require immediate action. Crew action can be taken after consulting the Quick Reference Handbook and considering all the options. Level 3 alerts are warnings. They are accompanied by both red master warning lights flashing. These situations require immediate corrective action. They cover emergencies such as serious system failures and hazardous aircraft configurations. Along with the flashing master warning lights, Level 3 alerts are accompanied by a continuous repetitive chime. In addition, a red light illuminates on the crew alerting panel. This light provides an indication of the nature of the problem. The crew alerting panel divides annunciators into two groups, the master warning group and the master caution group. Red lights are associated with the flashing red master warning lights, and the amber lights correspond to the flashing master caution lights. Each individual cap lens has two bulbs. These bulbs can be checked with the annunciator light test switch during the pre-flight. The cap alerts can be recalled, cleared, or inhibited with integral push buttons. These buttons are labeled Recall, Clear, and Takeoff Inhibit. The Clear button will extinguish any amber cap lights, as well as reset the MFC for that particular system. If the cap is not cleared following a failure or fault, the crew won't be alerted to any subsequent faults of that system. For example, if a bleed valve failed and the cap was not cleared, the other bleed valve could also fail, and the crew would not be alerted. Pressing the Recall button will bring back any existing faults that were cleared previously with the Clear button. This is performed during the descent and approach phase to remind the crew of any conditions that might have been cleared from the cap. The Takeoff Inhibit button is pressed before takeoff to inhibit Ccas alerting for non-emergency conditions during the takeoff roll. Smoke warnings and engine oil are the only Level 3 warnings inhibited by the Takeoff Inhibit button. All Level 2 warnings are inhibited except for EFIS comparator, parking brake, GPWS fault, maintenance panel, engine, and flight controls. The inhibit is cancelled and the inhibit light goes out when the landing gear unlocks for retraction or the recall button is pressed. Nuisance or false alerts can be silenced with the emergency audio cancel toggle switch, located on the right side of the center pedestal. Movement of this switch will silence whatever alarm is currently sounding. Any other alarms will still be heard. When an affected system alert has been canceled with the emergency audio cancel switch, the affected system will not provide another warning for that condition unless the MFC has been reset by cycling aircraft power. MFC 1B, 2B is reset. The recall push button is pressed. Or the takeoff configuration is tested. This would generally apply to Level 3 warnings, since those are accompanied by a continuous repetitive chime. However, there are a few exceptions for some situations. In these cases, the system will rearm once the triggering condition is removed. These situations are: the landing gear is not down, a VMO, VFE, VLE overspeed, the stall warning cricket sounds, the pitch trim wooler sounds, or the autopilot disconnect. GPWS alerts are not affected by this switch. Next to the emergency audio cancel switch is the takeoff configuration test push button. This button is pressed before every takeoff to check for correct aircraft configuration. The test works by simulating the power levers being placed in the takeoff position. The system checks that the flaps are in the takeoff position. Pitch trim is in the green arc. The aileron lock is disengaged. The power management rotary knob is in the takeoff position, and the travel limiting unit is in the low speed configuration. There will be no alerts if the configuration is correct. If the configuration is incorrect, the master warning lights will flash, the continuous repetitive chime will sound, and configuration will illuminate on the cap. Along with configuration, the flight control light will illuminate on the cap if pitch, trim, or flaps are not correctly positioned, or if the aileron lock light is illuminated. Engine will illuminate if the power management knob is not in the takeoff position. The configuration light also illuminates if the TLU fault light is illuminated. The parking brake is not monitored by the takeoff configuration test. There is a built-in redundancy to handle a failure of the Ccas system itself. If MFC 1B and 2B fail, the master caution lights will illuminate with no aural warnings. MFC will be enunciated on the cap, and MFC 1B and 2B fault lights will illuminate on the overhead panel. Following an MFC 1B and 2B failure, the following alerts will not be processed. All Level 2 alerts and the following Level 3s: configuration, engine oil, and propeller brake. The rest of the Level 3s will only be processed by the cap. In other words, there will be no flashing master warning lights or continuous repetitive chime. Now we'll take a look at the specific conditions that trigger aural alerts. Altitude alerts are provided whenever the aircraft altitude approaches 1,000 feet of the target altitude selected on the advisory display unit. It also signals entering the 250-foot capture zone. This alert is a bong, or C-chord sound. Flight attendant and mechanics calls are made via the Ccas. The overspeed alert, or clacker, is heard any time there is an overspeed condition for VMO, VLE, or VFE-VFO. The pitch trim wooler sounds any time the pitch trim is in motion for more than 1 second. Stall warnings are detected by the angle of attack probes. When a stall is sensed, the Ccas will produce an aural alert and the MFC will activate the stick shaker. When the angle of attack becomes excessive, the MFC will activate the stick pusher. The stick pusher is operational as long as any 2 MFC modules are operating. The triggering threshold for stall warning varies with power setting, flap configuration, and when the icing AOA button is illuminated. Normal stall warning occurs at 10.9 degrees angle of attack in non-icing conditions. In this case, the icing AOA light would be extinguished. In icing conditions, the stall warning occurs between 7.7 and 8.4 degrees AOA in cruise, depending on the flap's position, or 8.4 degrees within 10 minutes of takeoff, or until the flaps are retracted. The stall alarm and stick pusher are inhibited when the aircraft is on the ground. Stick pusher triggering varies between 10.6 and 14.3 degrees AOA, depending on the same factors. These factors are power setting, flaps, and horn anti-ice selection. The pusher is inhibited during the first 10 seconds after takeoff, as well as within 500 feet of the ground, provided the radio altimeter is working. This concludes the Crew Alerting System module.